Happy morning students. Welcome to grade 10 mathematics online class. Okay. In the last class we learned how to draw similar triangles based on proper and improper fraction. Have you all done the homework problem? Only one homework problem I gave. And the last class we started the second chapter also. What is the heading? Do we remember? Numbers and sequences. And today we can continue chapter 2, numbers and sequences. This is the last question we deal in the last class, correct? Example 2.2, there are 3 subdivisions, 1 subdivision only we completed. Shall we see the remaining problems? Okay, let's recall the first problem one more time. Have you learned the Euclid's division lemma? What is the Euclid's division lemma? Let A and B be 2 integers, then there exist 2 unique integers, Q and R, such that A is equal to B, Q plus R. What is the condition? 0 less than or equal to R less than B. That is for integers. But for positive integers. But for integers, what is the generalized lemma? Hereafter we are using the generalized lemma only. A is equal to B, Q plus R. 0 less than or equal to R less than modulus of B. So here, for whenever we are going to find quotient and remainder, we can use this Euclid's division lemma. So A is divided by B. Here, A and B. So we need to write the formula A is equal to BQ plus R. The condition I written 0 less than or equal to R less than modulus of B. So here minus 12 in the place of A, the place of B 5. We need to find Q and R. So what is the condition for R? R should be positive number. So in that case we need to select Q. Okay. Then we need to get minus 12 as answer. By that we are getting quotient and remainder like this. Shall we do the second problem now? Okay, dear students, listen. A is equal to 17, B is equal to minus 3. So, by Euclid's division lemma, what is the condition? A is equal to BQ plus R. Then, separate condition 0 less than or equal to R less than modulus of B. So, just substitute the values for A and B. A is equal to 17. B is equal to minus 3. Okay. So here Q value we need to find and R value also we need to find. What is the condition? 0 less than or equal to R less than, here modulus of B, modulus of minus 3. So 0 less than or equal to R less than, what is the value of modulus of minus 3? That is 3. So what should be the remainder? The remainder may be 0, otherwise may be 1, otherwise may be 2. So in this place, among these 3 numbers, any one number will come. So based on that, you need to consider Q. Okay. So 3, here we are getting, here we need to get positive number only. So answer also positive. So minus into minus only positive. So here should comes minus number. So guess the numbers. 3 5s are 15. So plus 15 plus 2. It will come correctly, no? Guess the number you need to put here. But for remainder, it should be positive number. But quotient, it should be negative, otherwise positive. Any number you can take. So what is the quotient here? Quotient is equal to minus 5. What is the remainder? We need to calculate quotient and remainder. So remainder is equal to 2. Shall we do the third problem now? Third problem, A is equal to minus 19, B is equal to minus 4. So the same thing by Euclid's division lemma, A is equal to BQ plus R. So 0 less than or equal to R less than modulus of B. So modulus of B. So A is minus 19, B is minus 4. So Q plus R. So 0 less than or equal to R less than modulus of B, that is minus 4. So 0 less than or equal to R less than 4. So what should be the remainder? It may be 0, it may be 1, it may be 2, it may be 3. So among these 4 values, any one number will come here. So be confident in that. And it should be a positive number. Correct only, no? So here answer should be in negative. So 4 into which number? 4 5s are? Yes. 4 5s are 20. So here comes minus 20. Minus 20 plus which number will come? Minus 19, 1. So be careful, the remainder should be positive. Okay, that is the condition, because here the condition is Less than 4, no. So 0, 1, 2, 3. Among these 4 numbers, any one number will come. So what is the quotient? Quotient is equal to 5. What is the remainder? Remainder is equal to 1. That's all. Okay, students. Here, in the same page 38, there are some progress check. Have you seen that? See. In the page number 38 of your Maths textbook, here's some progress check based on this model. Find Q and R for the following pairs of integers A and B satisfying A is equal to BQ plus R. So, these 5 problems homework you need to do. Okay. There is no book back answer for this. The next class I will give the answer for this. So, progress check these 5 problems. After this question, whenever you are writing this question now, example 2.2, after this example, you need to do this homework. Okay, students, there are 5 questions, very simple. Using this model, you can refer this model for a reference. Example 2.2 model, these 5 problems you need to do as a homework. Then you will get a clear idea about this. Next class, I will give the answer for these things. Okay, students, shall we move for the example 2.3 now? Easy problems only. Okay. Listen, dear students, there is one word problem. Show that we need to prove the square of an odd integer is of the form. We need to select an odd integer. We need to take the square. The answer will be in the form 4q plus 1 for some integer q. Okay, this is the wordings. Let's see for the real example. The square of an odd integer. Say one odd integer. Any one odd integer you can say. Odd integer means 3, 5, 7, 9, 11, 13. Okay, that way odd integer. Select any one odd integer. 7 is an odd integer, correct? Otherwise 3 is an odd integer. Then 9 is an odd integer. 11 is an odd integer. This for example. For your understanding only I am writing. So this odd integer when we taking square. So take the square. The answer is 9. Here the answer is 49. Here the answer is 81. Here the answer is 121. Correct? The square answer, the square of an odd integer, the answer will be, we can write in the form 4q plus 9. How? So 3 square is 9. I am writing 4 into 2 plus 1. Correct? So 4 into q plus 1. Q is some other integer q. Q is any integer. So 9 can be written as 4 into 2. 4 2s are 8 plus 1, 9. So square of an odd integer can be written in the form 4q plus 1. This one satisfied. So let's check for the 7 square. 7 is an odd integer. I am taking square. The answer is 49. The 49 can be written as 4q plus r. How? 4 into 12, it will come correct now, 4q plus 1. So 48 plus 1. So 4q plus 1. In this format we can write any odd number square answer we can write in this format. So this is also correct. Shall we check for the next one? 9 square. 9 is an odd number. When we take square we are getting 81. So we can write 4 into 20 plus 1. So 4q plus 1. This is also we are getting the correct format. If you check 11 square, you will also get the same format like this. So for numbers we put correctly, but we need to prove in the general form. Okay, not for giving numbers. This is for your understanding. No need to write this as the fair answer. This is for understanding I am explained. So just come to the concept. Show that the square of an odd integer is of the form 4q plus 1 for some integer q. We don't know which integer, odd integer, we don't know that what integer we need to take. So let x be any odd integer. X be any odd integer. So x is the odd integer, correct? X equal to odd integer. Listen, 2k means whether it is even or odd, multiples of 2 are always even, correct? If we add one number in addition to that, it will come to the odd number, correct? Because 2 multiples, 2 4s are 8, 4 plus 1, that means 8 plus 1, 9, that is an odd integer. So, I need to take an odd integer. The format I am taking is x equal to 2k plus 1. Why I am taking like this means 2k is always an even number because multiples of 2 are always an even number. If we add one number to that, it will change into the odd integer. So, odd integer format. If you put k is equal to 2 means what will be the number we can get? 4 2s are 8, 8 plus 1 9. Odd integer we are getting. If k is equal to 10 means what is the integer we will get? 10 2s are 20, 20 plus 1 21. Odd integer only. So the general format of an odd integer is 2k plus 1. Let's study this. Okay. So odd integer we took. We need to take the square. So now x square is equal to, we are going to take the square, 2k plus 1 the whole square. This is the formula, a plus b the whole square. So a square plus 2ab plus b square, which is equal to 2 square is 4, k square is k square. So 2 2s are 4k plus 1, which is equal to, here among the two numbers, first two numbers, what are the common numbers? 4k is common. So inside the bracket what will be the numbers will come? K plus 1 plus k. So which is equal to, we need the format 4q plus 1. So 4 here this full term I am taking as q. So plus 1. So where q is equal to, what will be the numbers? K into k plus 1. I am replacing some integer. So we got the point now. So x square is equal to any odd integer. This is one odd integer. 2k plus 1 is an odd integer. How? 2k is an even integer. Any even integer, if you add 1, it will change to odd integer. So for an odd integer, if you are taking square, the final answer is in which format? 4k plus 1. Got the concept, students? Okay, shall we move to the next one? Euclid's division algorithm. The first thing we learnt Euclid's division lemma. Now we are going to learn Euclid's division algorithm. Okay, let's listen. Okay, dear students, listen. Euclid's division algorithm, theorem 2. This 4 lines also you need to learn. Okay, if a and b are positive integers such that condition a is equal to bq plus r, then every common divisor of Euclid's division algorithm is used to find the HCF. HCF or GCD, both are same only. So Euclid's division algorithm is used to find the HCF of two numbers. So then every common divisor of a and b is the common divisor of b and r and vice versa. Okay, just I am giving one example. While seeing the example, you will get the theorem easily. Okay. Okay, dear students, listen. Here, on example, we are going to find the HCF of 273 and 119 by using the algorithm. This division algorithm we are going to use. The method is, listen carefully. First, you need to select the biggest number as A. So, which is the biggest number? 273. So, B is 119. Got it? So, A value and B value. First, we need to divide A and B. The common divisor only we need to find now. So we are going to divide. So 273 divided by 119. Rougher we can write here. So 119 into 2 times how much will come? 9 2s are 18. Here 3 and 2. 238. Correct? So 2 times it is 238. And the remainder is here 13. 13 minus 8 is 5. Here 6, 35. Okay, the steps I am writing here, it will go like this now. So 273 equal to, in this format you need to write A is equal to BQ plus R. So A is equal to 273 is equal to B value 119 into Q value quotient 2 plus remainder is 35. So the remainder is not getting 0. So we need to repeat that. The common divisor of A and B is the common divisor of B and R. Next, remainder. Remainder value we need to take it as the divisor. So listen carefully. First, larger number we need to put inside and smaller number we need to put outside. We need to divide and find the quotient and remainder and want to write like this. Here the remainder is not 0. So we need to repeat this until we are getting 0. We need to repeat this. So 35 now become divisor. You need to put like this. We need to repeat this step by step procedure. That is algorithm. Okay. Now this 35 becomes, what is that? Divisor, and this dividend will come inside. So 119 will come inside. So 35 table we need to write. So 35 into 3, how much? 15, 10. It will come correctly, I think so. So 3 times. 3 times means 105. So what is the remainder? 14. Again we need to write like this. Now this is A, inside value A. So 119 is equal to outside value B. Remainder is in the up. Sorry, quotient is in the up and the remainder is like this. Here also the remainder is not getting 0. So we need to repeat. This becomes divisor and this divisor becomes the dividend. Now 14 into 2, 28, correct. So 2 times 28 and 5, 7, no, 7 is the remainder. So here also we are not getting the remainder is 0. So this step we can write inside value A, outside value B, up value quotient, remainder is 7. Here also we are not getting the value as 0. So we need to repeat this. Until we are getting 0, we need to do this. Okay. This is the method of division algorithm. Algorithm means step-by-step procedure for finding the HCF of given two numbers. It's very interesting problem. Then this divisor becomes this remainder becomes the divisor and the previous divisor becomes the dividend. Now 7 2s are 14. Now we got the answer is 0. So what is the last format? 14 is equal to, A means inside value, outside value 7 into 2 plus 0. Now we got the remainder is 0. So the remainder at this stage is 0. Therefore at this stage, what is the divisor? Divisor is equal to 7. So the last divisor, whenever we are getting 0, no, that divisor is the HCF of 273 and 119 is equal to 7. So using division algorithm, we found the HCF of two large numbers. These steps you need to write using Euclid's division algorithm. Okay, using division algorithm, is it clear? Using division algorithm, we found the 4 steps. The final stage we are getting the 0. So only at that step we are getting the divisor is 7. So that divisor then HCF is equal to 7. The concept is clear now. Now come to the definition. If A and B are two positive integers, A and B two positive integers, such that the condition I wrote here, then every common divisor of B and A and B, this is the common divisor of A and B, no, these are the common divisor of A and B, is the common divisor of B and R. This B and R, the remainder. So the remainder, the next step, it will be the divisor. That wording is only this. The common divisor of first A and B changes to B and R. This B and R, the remainder, and vice versa. Vice versa means it will come continuously like this until we are getting 0. That is the concept. Okay, students? Okay, dear students, listen. There is one more homework problem. Exercise 2.1. See the 6th question. Use Euclid's division algorithm to find the HCF of 4 subdivisions are there. And today you need to complete 1 and 2. Okay, next class you need to do the remaining 2. So there one progress check 5 problems plus these 2 problems homework. These 2 problems you need to follow this method. Okay, there is one more example problem also there. I will teach that also. This problem you need to copy in your note. Okay, this is put one normal example, then only you will study. So this also you need to copy and you need to do the 2 problems in exercise 2.1. Okay, let's see example 2.4 now. Okay, dear students, listen. Example 2.4. If the highest common factor of 210 and 55 is expressible in the form, this form, we need to find x. So, highest common factor first we need to calculate. So, Euclid's division lemma we are going to calculate using, algorithm. Euclid's division algorithm. We are going to find the HCF of using division algorithm, find HCF of 210 and 55. Okay, shall we start now? So which is A and which is B? A is the biggest number. So biggest number we need to put inside. So outer number 55. So 55, how many times it may come? Any guesses? So 55. Just 1 second. Okay. So 55 into 3 we can put 15 and 16. If you are putting 55 into 4, it's a 20 and 22. It will exceed, no? So 65 is the correct. So 3 times 165. So what will be the remainder here? 5 will come and here 0, 10. So what will be the remainder? 45. Got it? So what is the first step? How we can write the first step? 210, which is equal to, A is 210. So A is equal to B, 55. This format, A is equal to BQ plus R. That format you need to write, okay? So A is equal to BQ, 3 plus what is the remainder? 45. So the remainder is not getting 0. We need to repeat this. Now this remainder becomes the divisor and the divisor becomes the dividend. Okay, this number you need to put inside. Then whenever we are saying, we are easily getting now for 45. So what is the remainder? 10. So 45 is equal to, 55 is equal to, A is equal to B. 45 into quotient plus remainder 10. Got it? Here also remainder not getting 0. So again we need to do. So put like this. Now this becomes the divisor and this becomes the dividend. So 45. So how many times? 4 times. So 40. Remainder is 5. We need to write here. A is inside value. B is outside value into 4 plus 5. And this step not over. The remainder is not getting 0. So again we need to do. This number will come here. So 5 2s are 10. Now we are getting the answer is 0. So what is the last step? Inside value 10. Outside value here 5 into 2 plus 0. At this stage we are getting the remainder is 0. So we are getting the remainder is equal to 0. So what is the HCF? The last divisor is 5. So that is the common divisor of the given number. So HCF of 210, 55 is equal to 5. And what is the question given? The HCF of these two numbers, this 5 is expressible in the form. So this 5 is equal to, given the HCF of two numbers is expressible. So is equal to 55x minus 325. So we already found the HCF of this is 5. So 5 is equal to 55x minus 325. From this we need to calculate the value of x. Easy, no? So 5, when transposing this number this side, 325, which is equal to 55x. So just add this 330, which is equal to 55x. So x equal to 330 by 55. Cancel for which table? 11th table, no? So 30 and here 5. So x equal to 30 by 5. So x equal to 6. This is the answer. Got it, students? Very, very simple problem. Here HCF of these two numbers, equal to the given format is given. So first we need to calculate that answer. So by using division algorithm we found that answer. Then substitute in this place. Then easily we will get the value of x. Okay, easy now? Okay dear students, listen. Example 2.5. Find the greatest number that will divide 445 and 572, leaving remainders 4 and 5 respectively. Understand the question very clearly. We need to find the greatest number that will divide. One number is dividing these two numbers and leaving the remainders 4 and 5 respectively. There are more numbers which will divide this. We need to find the greatest number. Got it? So, since we need to neglect the remainders first. After that, we need to find the HCF. That's all the concept. So, since the remainders are 4 and 5. Here, the two remainders are 4 and 5. The required number, this greatest number is the HCF of which two numbers? We need to eliminate the remainders first. So, 445 minus 4 is equal to, and 572 minus 5, which is equal to. So, what are the answers? Say the answers. 445 minus 4 is 441. And here 572 minus 5 is 567. Then we need to find the HCF of these two numbers. That is the required answer. So here two numbers are given. The leaving reminders. So if we minus the remainder means we will get two numbers now. That number HCF only we need to calculate. Now HCF of 441 and 567 we need to calculate. So by Euclid's division algorithm we can use by Euclid's division algorithm. So highest number we need to take. A is equal to BQ plus R. That is the normal format we know, correct? So here we can do the calculation. For the first number, biggest number we need to select 567 divided by 441. So how many times it may go? Only one time. So one time 441. What is the remainder? Here 6, here 2 and here 1. So how can we write? 567 is equal to B value into Q value plus R value. The remainder is not getting 0. So again we need to repeat this. So this divisor becomes the dividend 441. So how many times it may go? Shall we check for 3? For 6 3s are 18, balance 1. Then 7. So 126 into 3. 18, 6, 7, 378. So 378. What is the remainder? 11 minus here 3 and here 13 minus 7 is 6. So 63. Again we are not getting 0. So we can write this. A inside value, B is outside value, quotient is 3 and the remainder is 63. The remainder is not getting 0. We need to repeat this. So now this divisor becomes the dividend. So here how many times? 2 times. It will come correctly, no? 126 and this at this stage we are getting the remainder is 0. So 126 is equal to 63 into 2 plus 0. So at this stage we are getting the remainder is 0. So what is the HCF of 441, 567? What is the last divisor? 63 is the last divisor. So what is the required number? Required number is equal to 63. So the only concept, the reminders, these are the extras. No, these reminders we need to subtract first, and that subtracted answer we need to find the HCF. Because the greatest number they asked, no, so we need to find the HCF by Euclid's division algorithm. That's all, very very simple question. So next one theorem is given, and after that on example 2.6 is there. Then exercise problems more, 10 exercise problems are there. So one by one we can see. Now come to example 2.6. Okay dear students, listen. In example 2.6 we are going to find the HCF of 3 numbers. Okay, you can refer your textbook page number 42. How can we find the HCF of 3 numbers? Applying division algorithm, 2 times we need to find. For the first 2 numbers we need to find the HCF, and by the answer of the first 2 numbers and the last number we can find the required HCF. Okay, now see this question example 2.6, we can get it easily. Okay, find the HCF of 3 numbers. So first select 2 numbers. After getting the answer of HCF, we will find that answer with the third number we need to find. Okay students? Okay, listen. So solution. First select the first 2 numbers 396 and 504. Okay, so which is A? The biggest number is A. So by Euclid's division algorithm, listen dear students, by Euclid's division algorithm A is equal to BQ plus R. So the biggest number 504 inside and 396 outside. First 2 numbers we are going to find. Okay, so it is one only possible. So the remainder not getting 0. So how can we write? 504 is equal to 396 into 1 plus 108. Now this divisor becomes the dividend. So 396. So how many times? So 3 times. 3 times when we are taking means 324 and the remainder is 72. Here also we are not getting 0. So 396 is equal to 108 into 3 plus 72. Again we need to repeat this. So now see this. this 108 will come inside and 72 one time and the remainder is like this. Here also we are not getting 0. So 108 is equal to 72 into 1 plus 36. Now see this, here also is not 0, no? Now this divisor becomes dividend. So here automatically we are knowing that is 2 times. So 72, the remainder is 0. At this stage we are getting the remainder is 0. So the last step, 72 is equal to 36 into 2 plus 0. So the remainder is equal to 0. So what is the HCF? HCF of 396, 504 is equal to last divisor 36. Then the first two numbers HCF we found, and by this answer and the next number we are going to find the HCF. Got it, students? Now listen carefully. The answer and the third number we are going to find. Okay, listen. Okay, dear students, listen, I solved this. So HCF of the answer and the third number. See the procedure for finding three numbers. The HCF of three numbers means first two number HCF we need to find. After getting the answer for this, the answer and the third number we need to find. So the same procedure like this. Here also we need to write like this. 636 equal to the format is very familiar for you. You need to write this 24 and then 36 equal to 24 into 1 plus 12, and at the last step 24 is equal to 12 into 2 plus 0. So at this step we are getting the remainder is 0. So what is the required HCF? HCF of 36 comma 636 equal to 12. So what is the final answer? Important final answer. The HCF of three numbers, that is also 12. 396, 504 and 636 equal to 12. So see the difference. For finding two numbers, this step only. For finding three numbers, first two numbers you need to select and find the HCF, and by the answer and the third number you need to find the HCF. We will get the required answer. That answer is the final answer for HCF of the given three numbers. Okay, students, today we can stop up to this. The examples, all the examples before 2.1 over, and you can mark the homework problem, this two problem. Sixth one, first and second, and before that I told no progress check. This 5 problems also you can do. And in the next class we can see the remaining problems in the exercise. Okay. Okay, students, have a nice day. Thank you.